Hey all, okay, last section, 11.2 logarithms. So what logarithms do is they find exponents. If you think of a problem like, what do I raise 2 to get 8? That one's pretty easy, right? Because we can go, 3. 3 would work. And so we just kind of look at it and work out that it's 3 by going 2 times 2 is 4, times 2 makes 8. Cool. What if I asked, what do I raise 2 to get 7? All of a sudden, that's a really hard question, and we do not have a good way of figuring that out. We know it's going to be a little less than 3. If I do 2 squared, that would be 4, so it's 2 point something. And then after that, if we don't have logarithms, we would just sit there and try things, and that's not a good way of getting there. So what logarithms end up doing for us is telling us what is the value I should raise 2 to make it come out 7. So logs solve exponentials the same way that, like, if I have roots or squares, I can solve those using roots. So same relationship between logs and exponentials as squares and square roots. Boy, the notation on these is tough when you first meet it, and that's pretty much all we're trying to get to in this course. Is we're going to look at converting between the two forms that we'll see these in, solving little log equations that are coming up here in a second, and then using a calculator, because often with logs there's if we're looking for a decimal answer, it's definitely a calculator thing. So the two forms, and this is sort of the guts of it, is right here. We're going to have this log form and exponential form. I'm going to write that a little bit bigger over here just so you can see it a little bit better if you're watching on a small screen. Log base b of x equals y, and b to the y equals x. So let me read the definition. B to the y equals x is equivalent to log base b of x equals y. So these two things are the same thing. Notice when we had exponentials before, right? It was b to the x equals y, not b to the y equals x. So that x and y are reversed here. So this is exponential form of a log. So anyhow, these are the same thing. And this is saying y is the number we raise b to in order to get x. So y is the number we raise b to in order to get x. Looking at that in log form is harder. So it's b, what do I raise b to get x? And the answer is y. That's what a log does, is it finds exponents. So this y is the exponent. This is so much better with some numbers in it, so I'm going to do the same thing. That's the general form. This just hurt my brain when I was a student, so let me show you what I did. Because I did that. Log base 10 of 100 is 2, because I could look at this and go, okay, that's because 10 squared makes 100. 10 squared makes 100. So this is asking, what power do I raise 10 to get 100? And then that, with some numbers there, I can get my brain around it and go, 2. Okay, that makes sense. 10 second makes 100, or 10 squared makes 100. So that's what we're trying to get in this section, is basically just understanding how this notation is working and that these are the same thing, and then finding the button on the calculator so we can evaluate them. So let me show you a little bit more. Oh, sorry, I almost forgot base 10. So with base 10, the same way with a square root, it's plain like this. If we were going to write a cube root, it would get a little 3 up there in the index indicating it was a cube. The square root, this little 2 is implied. That's the same thing as if I write log 100. That's the same thing as writing log base 10 of 100. The base could be anything that is greater than 0 and not 1, same as the exponentials. But if there's nothing there, if there isn't like a 2 or 5 or something saying what this is, that invisible thing is a 10, and that's called the common log base 10. It gets used a lot. So for that one, they simplified the notation so they didn't have to do the subscript. Okay, so what's this look like in terms of the problems? We have these first couple of versions where we're convert between exponential and log form. So write the answer in log form. So the one thing that really helped me when I was kind of figuring out how to do these is realizing that the base stays the same. And so when I go from exponential to log, and let me write the two forms up here so I can point at them. Log base b of x equals y, because b raised to the y makes the x. So the base of the log and the base of the exponential are the same thing. It's the x and the y that are swapping places. And again, that's that inverse relationship that you'll see if you go on to 141. So here, I'm going to have a log base 5. And then this is saying the exponent I raised 5 to get 43. So in log form, this would be, what power do I raise 5 to get 43? I don't know, that would be the x. And so this is going from exponential to log. Same thing right here, written the other direction. There's my base. So I could write this as log base 10 of this value. And remember, the exponent is always the answer for the logarithms. So of 0.001 equals -3, or 10 raised to the -3rd makes that 0.001. The other way that I could write this, and it's also totally correct, is using that common log notation. So both of these answers completely right. So that's going from exponential to log. And now what I think is actually easier is going from log to exponential, because our brain is way more comfortable with 7 squared really does make 49, right? So if it doesn't have the numbers in there, it makes it a little bit harder, but to me that seems easier to think of it this direction. I think because I'm going the direction that my brain wants to, as opposed to into this log notation. So here, we just rewrite it as 7 raised to the 2nd would make 49. And again, this is asking, what power do I raise 7 to? So that's what the word log means. It means, what power do I raise the 7 to get 49? And then that answer is 2. So this is asking, again, just for exponential form. So 6 and then raised to the 0 makes 1, which makes sense because anything to the 0 makes 1. Okay, next up, solve for x by writing the equation in exponential forms. This is solving little logarithm equations, and again, it's just sort of practicing with that notation and kind of getting used to the idea of what it's asking for. So this one's saying log base 5 of x equals 2. That's how you'd read it. But what it's asking is, it's asking 5 squared would make what value? And so that's not hard at all. 5 squared would make what value would be 25. And so it's just kind of getting it in this order that your brain is going to be more comfortable with. And then it would be log base 5 of 25 makes 2. So 5, what power do I raise 5 to get 25 squared? Does that make sense? Same idea over here. And again, what power do I raise 2 to get 16? That is 4. Right? X, what power do I raise 2 to get 16 would be a 4, and that would be the exponent. It's hard to jump from here to here, so doing that little rewrite can really help. What power do I raise 2 to get 16? And then seeing it written in this order, you can do something, you don't have to write this step at all, but the reason this works is because 2 to the x equals 2 to the 4th, and so x must be 4. Okay, so then for this next one, this has an invisible 10 down here. So let me rewrite that. So that's that base 10. And then this is just saying, what power 10 raised to the 2nd makes what? So 10 to the 2nd makes x, so x would have to be 100. What power do I raise 10 to get 100? 2. Yeah, that makes sense. So x would be 100. And then this one, x squared makes 81. And then the base cannot be a negative value. So when I do the root, I don't want the plus or minus this time, because it's true that -9 and +9 both solve this equation, but only 9 makes sense for the base of the exponential. So that would be a 9. And then lastly is just finding the log button on your calculator. And so your calculator may have a couple of log buttons. Mine has where I can put a base in. Let me raise it up a little bit, which is nice. So if I had to do log base 2 of 7, I can do it there. The one that says plain log, which is the one every calculator will have, they won't all have that one. This is your log base 10 value or button. So you just go log. And then if your calculator says error right there, that's terrible. That means that you have to go 5,000 log, and you don't want that calculator. It's fine for this course, but if you got to take like pre-calc, that calculator is going to be terrible for you. You want one that goes log number is sort of the normal. Let me just throw in the 5,000. So what do I raise 10 to get 1,000 would be 3. So this should come out a little bit bigger than 3.69. 4 would have been 10,000, right? So it had to end up in between there. And then likewise, this last one, oh, and then it's asking us to find the value to 4 decimal places. So this is 3.6, let me write it under the right one, 3.6989. And then it asks us to round to 4 decimal places. So here I wrote it out. So this will be 3.69. So the 7 would make this a 0, and then that's going to make that a 9. So 6990. And then this last one, we'll just go log of 0.053. And then this one's going to come out to a negative number, -1.2757. And then that would be a 2 on the end, so that would drop off when we rounded to 4 decimals right there. And it makes sense that this is negative, right? Because something smaller it'd have to be 10 to the negative something to come out to a fraction, to come out to a decimal. So that's what we would expect for a decimal, is a negative. And that wraps up logs.